Basic knowledge of wireless communication. What is a communication protocol? Different digital devices, such as smartphones and PCs, can exchange text, images, and other data as a matter of course. One of the reasons such interchange is possible is the existence of defined rules and conventions for communication. This time, we will take a look at communication protocols. Communication protocols are the rules necessary for both wireless and wired communication. In fact, to reliably transmit data, establishing an extremely large number of rules is necessary for the modulation method, data structure, communication control, communication procedures, and more. If we were to consolidate all these numerous rules into a single protocol, attempting updates such as adding or changing some of the rules would make it necessary to keep an eye on the entire protocol. That would increase the burden of performing updates. Accordingly, to facilitate easy updates, protocols are layered with roles and functions assigned to each layer to form a layered structure for the entire protocol. This is called a protocol stack. This protocol stack is modeled as an international standard. It is called the OSI Reference Model. The OSI Reference Model is comprised of 7 protocol layers like this. The data link layer is divided into the MAC sublayer and LLC sublayer. The relationship between the communication protocols in the OSI Reference Model and the movement of data during data communication can be visualized as follows. Data in two-way wireless communication also moves via a communication protocol like this. This OSI reference model is not actually used as a communication protocol. A suitable communication protocol is used according to the product or application based on the OSI reference model. As examples, we will look at the TCP/IP model, the communication protocol used for internet connections, and the Wi-Fi model and LTE model, the communication protocols used in smartphones. First, let's take a look at the TCP/IP model, which should be considered as the foundation of communication protocols. This model is comprised of 4 layers, based on the 7-layer OSI reference model. Layer 1 and Layer 2 of the OSI reference model correspond to the network access layer. The network access layer includes the same functions as the MAC sublayer and LLC sublayer. Layer 3's name changes to the Internet layer. Layers 5 through 7 correspond to the application layer. Following on, we will take a look at the typical protocols for each of these layers. Wired LAN Ethernet serves as the typical protocol for the network access layer. IP serves as the typical protocol for the Internet layer. TCP serves as the typical protocol for the transport layer. HTTP and SMTP serve as the typical protocols for the application layer. The relationship between the communication protocols in the TCP/IP model and the movement of data during data communication can be visualized as follows, using wired LAN as an example. Next, let's take a look at the Wi-Fi model. This model is also comprised of 4 layers. Layer 1 and Layer 2 are the same layers as in the OSI reference model. Layer 1 and Layer 2 differ from the TCP/IP model. Let's touch here upon the differences between the wired LAN and wireless LAN communication protocols. Only the physical layer and the MAC sublayer are different. The layers above that are common to the protocols in the TCP/IP model. The relationship between the communication protocols in the Wi-Fi model and the movement of data during data communication can be visualized as follows. Furthermore, the physical layer and data link layer have unique specifications in mobile 4G communication. However, protocols common to wired LAN and wireless LAN are used in the network layer and above. The relationship between the communication protocols between 4G terminals and base stations and the movement of data can be visualized as follows. Similar to 4G communication, 5G communication has unique specifications for its physical layer and data link layer. However, protocols common to wired LAN and wireless LAN are used in the IP layer and above. In this way, mobile communication protocols enable internet connections by sharing protocols for the IP layer and above with the protocols in the TCP/IP model. This sharing is an example of the benefits of a layered structure. We have so far explained that communication protocols have a layered structure and given the benefits of a layered structure with concrete examples when it comes to achieving interconnection. The protocols in each layer of communication protocols have various roles. Together, these protocols function as a unified system that enables interconnection, security, and more. This achieves highly safe and reliable communication. Just as hardware underpins existing and future digital communication devices, communication protocols act as an important foundation for these technologies. We have reached the end of this video. In addition to this content, we have published wireless communication-related content on Murata Manufacturing's technical article site. Please take a look from the URL in the description. If you found this content interesting, please consider subscribing to our channel.